Good afternoon, everyone. Okay. The students will be joining shortly because at 4 p.m. their classes are getting over. I request Dr. Tribhuvan Singh sir to start the meeting
Yes.
and to introduce us today's honorable speaker.
Okay. Thank you, sir. So, good afternoon, all of you. Myself, Dr. Tribhuvan Singh, Assistant Professor in the Department of Computer Science and Engineering. I welcome everyone to 44th SOA weekly cabinet lecture webinar. The title of today's webinar is The Blockchain Technology, a Perspective on its Past, Present and Future. The speaker of today's webinar is Dr. Vimal Kumar Baghel, sir. Dr. Vimal Kumar Baghel is currently working as an assistant professor in SCSET at Bennett University, the Times Group, Greater Noida. He has more than 17 years of teaching and research experience. He earned his PhD and MTech degrees from MNIT Allahabad. His past research work is more focused on multipath mobile computing in heterogeneous networks for multi-interface enabled smart mobile devices. He has published more than 12 papers chapters in various reputed SCI, Scopus, Web of Science, and ESCI Index journals and conferences. Dr. Vimal is currently passionate about blockchain use cases and IoT devices. Now, I would request Dr. Vimal Kumar Baghel sir to continue this webinar.
Thank you, Dr. Tribhuvan, for such a nice introduction in the beginning. I would like to, first of all, I'd like to thank the CSE department, the organizing team for inviting me for this invited talk on blockchain technology. I'll be discussing on the current perspective, the history, and as well as what is the future that we are going to witness. So if you allow me, should I share my screen?
Yes, sir. Yes, sir. Sure.
Yeah, thank you. Let me share my screen. Hopefully my screen is visible to all of you now.
Yes, sir. Sure. Sir. It is visible.
Yeah. All right. So this is the roadmap for the today's session. So I'll start with the discussion of how we have witnessed the transitions in the computing paradigm in the computing or in the IT industry, and then I will start with the blockchain technology history, why we are interested in this growing coming up blockchain technology, the working of the blockchain, the different components of the blockchain technology, the popular blockchain technology platforms, use cases, how we can build the decentralized applications, the some of the present aspects, and what we are going to have in future. And in the end, I'll take some of your questions. All right, so we have witnessed since the start of the this computing computing devices. So we have started we have witnessed many transitions, like we are witnessing it from the centralization of computing power, storage, infrastructure, protocol, and code towards the distributed computing. So in the beginning, we were having the mainframe computers. So the mainframe computers were basically, the all computing, storage, all the protocols, code that was centralized in a machine, and all the all the users were connected with those mainframe computers with their dumb terminals. That means their dumb terminals was not having any kind of processing or memory elements. So they were just sending their request to the mainframe. The request has been processed there, and the result is coming back to their machines. So that was the starting era when the mainframe computing was there. And then as the processing capability enhanced, so there was the emergence of the personal computers when the personal computers were having their own some of the memory computing power and the some of the input output devices that are attached with this. So this computing this with the emergence of this personal computers, so some of the processing was migrated from that centralized mainframe computer or a centralized server to the client devices. And then the next paradigm shift was in terms of the network computing. So that means we were having a network, and then all those personal computers were connected together, and then the processing has been done cooperatively, and then we were getting the results. So yes, and then after that there was a major shift. There was a major shift in terms of the internet computing. So with the emergence of internet, all the networks were connected together, and then the computing and the storage, the other infrastructure, the code, everything was also available on the various chunks of the networks. And then we witnessed the various evolution of the internet computing, like grid computing, and then recently the cloud computing. But now the paradigm is shifting again from the centralization, or you can say the distributed computing, towards the decentralization of all these resources. The major motivation towards this decentralization is we want to remove all the involved third-party servers or the involved third-party services from in between the users. So that is the main motivation. Now towards the decentralization, basically now the architectures are changing. With this paradigm shift, we are witnessing another shift in the computing paradigms. So basically with this paradigm shift, with the decentralized computing architectures, we are trying to offer the explicit control of all the digital assets to the clients, and we are basically trying to remove all the third-party servers and infrastructure, and we are facilitating that there is no need to trust anyone. The trust will be automated. So with the help of the decentralized computing architecture, the trust will be automated. And this shift is going to be possible with the help of decentralized laser technology. So what this decentralized laser technology is, so that we have to first understand before understanding the other things which are there in the blockchain technology. So basically, to understand this distributed ledger technology, which is a technology infrastructure protocol that facilitates the simultaneous access, verification and validation, and the updation of the record keeping in an immutable way over a peer-to-peer network. So it consists of a distributed ledger. So we understand that ledger is a kind of a database. So that database is consisting a data structure that is spreaded across the multiple machines, and those multiple computer devices are basically spreaded across the different geographical locations and the regions. So this distributed ledger is facilitating us to keep the record of transactions independent of their locations, independent of their geographical locations. So we can say that a distributed ledger technology is a facilitator towards the blockchain, right? So we can say that DLT consists three main basic components. That is, one is data model, a language of transactions, a protocol that is used for building consensus amongst all the peers, all the nodes that are participating in the blockchain. So this data model is basically is responsible for capturing the current state of the ledger. So yes, we are interested in knowing the current state of the ledger, which consists the all the transactions, all the transactions that are occurring inside the blocks. And then we need to modify these or to make the new blocks or to update the existing blocks. So we need a language of transactions that is used for writing the smart contracts or the chain codes. So the languages like Rust, or you can say Golang or Solidity, they are being used for the purpose of the language of transactions inside the distributed ledger technology. Then we need because in blockchain there is a role of making a consensus, making an agreement on a particular transaction amongst all the peers, all the stakeholders that are participating in the blockchain. So that a protocol used to build consensus among participants, and when all the participants are accepting that transaction, then only that transaction is going to be recorded in the ledger and subsequently in the block. All right, so now let us discuss about some of the history of the blockchain technology. Formally, like we know that whenever a new technology comes up, the discussion started in the industry as well as in academics. So the discussion was started way back in 1982. That time it was not known as a blockchain protocol, but there was a proposal in 1982, and then two scientists known as Stuart Haber and W. Scott Stornetta in 1991, they have described a cryptographically secure chain of blocks. So from there onwards, the discussion picked up on the blockchain. And then the different proposals came up, and then there is a kind of proposal that consists the proposal about the Merkle tree. So Merkle tree is a kind of data structure that consists the summary of all the transactions that are stored inside the block. So that was proposed, and then slowly and gradually in 2008. In 2008, Satoshi Nakamoto proposed the Bitcoin term. That was the formal beginning of any kind of blockchain. So, and then we have witnessed the different types of public and private blockchains. Like Ethereum is a kind of a public or permissionless blockchain, and then in 2015. The private blockchain, or that is also known as the enterprise blockchain, that was started through the Linux Foundation with the help of some of the open source proposals. And then now we are going to witness about the Ethereum 2.0 that is part of the industry 4.0, right? So that is launched already, and a lot of test network like Ropsten and some of the Covens. So they have already migrated to Ethereum 2.0 with their updated EVMs. So if we can see this timeline, that how the blockchain has evolved over a period of time, but still the blockchain is running in its infancy. the blockchain is going to be adopted in the future by many of the business houses, many of the industries, but still it will take some of the time, some of the maybe down the line 2-3 years. So then we will be able to see more and more applications, more and more business logic is shifting onto the blockchain platforms. So before proceeding further, we need to get the reason that why we are going to adopt this blockchain technology. Okay, so there are multiple reasons. There are multiple reasons like yes, the first and foremost reason is that we want to remove the role of all third parties, because the third parties are really making the things vulnerable or making the things slow. So because you are sending, like for example, we are doing the banking, so RBI or maybe some of the bank is basically recording all the transactions or holding or making the arrangement of our assets in terms of the like money or maybe some of the fixed assets like gold that is being procured by them and put into their custody. So yes, one thing is that we want to remove the role of third party ideally, and the second thing is that ideally the blockchain technology is going to be more faster, accurate, secure as compared to the existing centralized or centralized systems. Now there will be a sense of ownership. Like if you are holding your money, your assets, so you are owning them. Nobody else is managing that asset on your behalf. Right now, somebody else is basically managing those assets, but you are sending the like orders for them or requesting them to do the transactions, but they are doing the transactions on your behalf. But in case of blockchain, you yourself will do the transactions. You yourself will manage your store your transactions. Nobody will be able to see those transactions. All right. Although those transactions are available on all peers or all the stakeholders machines who are part of that blockchain, but they are not going to, only one person is not going to execute the transaction. That transaction will be executed with the consensus of all the peers, all the stakeholders. All right. So blockchain network can track orders, can do payments, can create, can manage the accounts and production, and it can do much more things. Right. So members like they are going to share a single view of the truth. They can see all the details of a transaction end to end, giving them a greater confidence as well as the new efficiencies and the opportunities with the blockchain technology. So I hope this thing is very much making sense that why we are going to shift to this blockchain technology from the existing centralized systems. But yes, there are some challenges that we're going to face in this paradigm shift. But once this is implemented, this is being adopted, then the performance and other challenges will get over. All right. So as we know that any business logic needs three things. That is computational infrastructure, storage infrastructure, communication infrastructure. So in blockchain technology also, we are going to have these things like the computing infrastructure, and then storage infrastructure and the communication infrastructure. So the computing infrastructure is inside the nodes, and those nodes are having a very high configuration with them in terms of their computing power, in terms of their storage, in terms of their bandwidth, that is communication bandwidths. So we can have a separate things also, like in blockchain we are having IPFS that is used for the storage purpose. We are having some Whisper kind of a protocol that are used for communication. So there are a lot of things that are specialized in terms of blockchain. Okay, so what we are going to change with this blockchain? Okay, so like we are going to remove the third party validations. We are going to remove this overhead. We are going to have a record keeping systems that are fully secure, and we can avoid, or we can get around with the vulnerability and the fraud, the cyber attacks that are being executed on these third-party servers. So that vulnerability will be removed as we will adopt the blockchain technology. So this limited the basically these third-party whenever we are using right now. So these things basically slow the data verification. So that is going to be changed. And with the arrival of the new technologies like IoT, the data, the transaction volume is going to be exploded. So in that case, we can have a solution with the help of the blockchain technology. So all these things basically will when we're going to use the blockchain technology, these things will become faster. So yes, so that was the reason that why we are going to have a shift onto the blockchain technology. So now we are going to have this clear understanding about the blockchain. So we can say the blockchain is a technology that is being used for running the trusted exchanges in the digital world. So as I said, there is no need to trust anyone. There is an automated trust that blockchain is going to have for us. All right. So the blockchain will consist a process of recording transactions executed by all the stakeholder peers through common consensus protocols in an immutable peer-to-peer distributed ledger, using some of the smart contracts and other facilitating technologies. So immutable means that once the block has been validated and verified and it is recorded into the blockchain, you cannot delete that block. You cannot modify that block. You can add a new block after improving or after modification some of the transaction, but you cannot delete that. So that is why we say that the blockchain is having an immutable property, or it is having an immutable component. And there is an automated trust, so there is no need to trust anyone. The trust will be provided automatically by the blockchain. So every stakeholder is going to have a copy of the distributed ledger that stores the transactions as and when the transactions are going to be happen. So the peers execute a consensus algorithm to validate transaction, group them into blocks, and build a hash chain over the blocks. So this hash chain is necessary because if we are going to have a hash chain, in this hash chain, the hash of the previous block is stored into the next block. Okay, so that is basically mandatory for maintaining the consistency of the blockchain. So these are the elements of the blockchain, that is distributed ledger technology that we have already discussed in brief. Immutable records, that is those records which cannot be tempered by any of the attacker without the consensus. And these immutable records are very securely stored onto the blockchain. And the consensus algorithm that are being used for creating an agreement amongst all the stakeholders, all the peers of the blockchain that are going to participate in that transaction. So once that transaction is validated, verified, and approved by all the participating peers, then only that transaction will be recorded into the blocks. Otherwise, it will not be recorded, it will be rejected. All right, so that consensus algorithm is one of the main and very important component in the blockchain technology. Like we have some of the consensus algorithm like proof of work, proof of concepts. So these are the like proof of work consist kind of a puzzle solving system where every node is given a puzzle. Whosoever is solving it first, that node will be given the chance to validate the blocks. So then the next component or element of the blockchain is the smart contracts or the chain codes. So smart contracts are basically simple programs, or you can say these programs are having the automated conditions, or you can say the time stamping. So as and when that time is satisfied, time condition satisfied, the smart contract is automatically executed. So a smart contract or chain codes are important part of blockchain. So whenever we are going to be a blockchain developer, we need to create the smart contracts. We need to develop the smart contracts in some of the language like Solidity, or maybe Golang, or maybe some JavaScript or Python also. So these are four main elements of the blockchain. Now, next we need to understand that how blockchain actually works. So we understood various elements of the blockchain. Now, this diagram, this slide is going to explain you that how the blockchain basically works. So whenever a client is going to have a transaction, like for example, if you are like, for example, suppose you're going to have or create a blockchain of the cars. Like for example, like cars are having the mileage. So if like people can tamper with the mileage odometer of the car, and they can falsely claim that their car has run only 50,000 kilometers, but actually that car might have run more than 1 lakh kilometer. So that kind of system can be solve that kind of problem, or fraud can be get around with the help of blockchain. So we can keep we can connect that car with the blockchain and keep the mileage odometer connected with the blockchain, and nobody will be able to change that block of records from the blockchain. So if somebody is some client is going to initiate that transaction, like maybe going to have the block for that car, their car, they are going to create a digitally signed transaction. So again, blockchain consists role of cryptographic algorithm, cryptography, like, so everybody has to, whosoever is interested in building their career in blockchain technology, they have to have the complete comprehensive understanding of the cryptographic algorithm. So like the client is going to sign that their transaction with the digital signature, and then that transaction is sent for the verification and validation to the over the peer-to-peer network for all the peers. Like here they are connected. So as we see here, every peer is having a copy of this transaction here. So these all peers inside this mesh topology, every peer is having the copy of this transaction, okay, of this so then every peer is going to have a validation over it. So if every peer is going to verify and validate it, then only that particular transaction will be recorded in a block, and then that block will be added into the existing blockchain. And once it is added, then the actual other stakeholders can also verify those or audit that transactions, right? So this is a abstract way how the blockchain works. Now we can have an example of Bitcoin. So everybody knows the cryptocurrencies nowadays very popular. So Bitcoin is like how the Bitcoin is being transacted from the wallet of the user A to user B. So we can understand with the help of these 6 steps. All right. So maybe there is a user A that the user wants to send some of the Bitcoins to user B. So then that transaction is digitally signed, and that transaction is sent to the peer-to-peer network, and then the transaction is mined by the miners. So all the stakeholders, or the persons who are or users who are that are part of the blockchain, they are playing a role of miner. So the transaction is mined and represented online as a block, and then that block is broadcasted to every node in the network, so that every peer is getting the copy of that transaction, and then the other nodes in that the network approve that the transaction is valid. So once this approval is done, then the block can then be added to the global ledger, that is the blockchain, and then that provides an then indelible and transparent record of the transactions. That means then the transaction on then the record cannot be deleted from the blockchain. Then the bitcoins are deducted from user A's wallet, and they are added to the user's B's wallet. So this is a very high level description about this transaction. But if you go into the low level, that how the transaction is occurring, how the wallet is being configured, like MetaMask is a kind of wallet that you can use, and you can use some of the smart contract that is interacting with the MetaMask, and that smart contract is then executing the transaction and taking some of the bitcoins from the user's A MetaMask wallet, and then sending that transaction for the verification and validation, and then from the MetaMask wallet of user A, those bitcoins are getting transferred to the wallet of the user B. All right, so that gives a clear understanding how the blockchain works. Now, we need to understand exactly what is inside a block. So basically, a block is a bunch of transactions that have been added to the blockchain. And as we see here, we have every block is having a version. It is having a Merkle root, as we discussed in the beginning, that Merkle root is containing the records or summary of all the transactions of that block. We have the hash of the previous block. In case of nth block, the hash of the n-1th block is there. We have a nonce, that is a random number. We have a difficulty target. We have the state of the transactions, that is that consists different things like smart contract, that is code, balance, and the storage, and then all the list of transactions. So every block is having all these things. So actually, what is a block? You can see all this thing is stored with the help of code inside some of the storage medium. And this block is again what? It is there inside the distributed ledger. And then that is being created, that is being stored on some of the, like maybe we are using some of the cloud for that sake. So yes. So we discussed about the consensus algorithm. So what the consensus algorithm is? So consensus algorithm is basically a process by which all the peers are reaching to a common consensus and on a common agreement about the state of distributed ledger. So if all the peers are reaching to a common consensus about a state of a transaction, then only that transaction is validated and verified. Validated only. Otherwise, if like maybe we can set some of the rules for that. Maybe we say that if more than 51% of the peers are approving it, then it is okay. So we can set that, we can customize those kind of things inside the consensus algorithm. So what is the smart contracts or a chain code? So as I said in the beginning, smart contract is kind of a program. Program is again a set of rules which is stored on the blockchain, and the distinguishing thing is that it is executed automatically as and when the conditions, timing conditions, or some of the predefined conditions are satisfied. So as we can say that we can create a smart contract for the transferring the salary of the employees on the last day of a month. Okay, so if we are writing a smart contract for that, so as the last day of the month is reaching, automatically that smart contract will be executed, and then the funds from the employer's account will be remitted to the employee's account, but in between that, all the validation will be done by the stakeholders. Also, we can have another use case, like we can have the corporate bond transfers, that we can also write the smart contract for that. Like we are having a maturity date for the corporate bond transfers. So on as that maturity date is reaching, that corporate bonds are transferred into the beneficiary's account. We can have some of the travel insurance use case also. So there are multiple use cases that are possible with the help of the blockchain. All right. So before discussing some of the specific use cases, let us understand a bit about the types of blockchain platforms. So we can have the private blockchains or the public blockchains. So like permissionless blockchains are the public blockchain platforms, and permission blockchains are the private blockchain platforms. Or also we have the hybrid kind of platform. So like we have a public kind of a system where there is no central authority. Everybody or anybody can join that particular public blockchain platform, like Ethereum. Okay, so Ethereum or maybe some of the blockchains which are coming up, they are using the Ethereum platform, and they are also a public kind of a blockchain. So Ethereum can join by anybody. Anybody can do the sale and purchase of the ethers by just getting into the public blockchain, Ethereum. And in case of private blockchain or permission blockchain, so it is also known as an enterprise blockchain. So an enterprise or an organization can also create a blockchain. So that blockchain is basically having all the stakeholders who are part of that organization. Like the person who are having a valid ID card of that organization will only be allowed to the member of that private blockchain. So this kind of blockchain was developed by the IBM in association with the Linux Foundation, that is known as the Hyperledger. So Hyperledger is a kind of private or enterprise blockchain that is being developed by Linux Foundation and in collaboration with IBM. Then we have some of the hybrid structures where the private and public blockchains are integrated together, and in which we have some of the controlling authorities, but some of the permissionless joining or signing in is also allowed. Also, we have a consortium-based blockchain in which this consortium-based blockchain is being controlled by a group. So we have some of the examples of the blockchain platforms. Like we have the Ethereum, we have Tezos, that is an Indian blockchain. We have Matic, that is also an Indian blockchain. Ripple, IPFS, Solana, Stellar, Near, Hyperledger Fabric, Polkadot, Neo, Cardano. So these all are some of the examples, platforms of the blockchain that are like either a permissionless or a permissioned blockchain platforms. All right. So as I said, that there are multiple benefits of the blockchain. Like there is an automated trust, there is a greater security. So once your your transaction is recorded into the block inside the blockchain, it is secure. So only insecurity is there when you are doing the transactions. So during the transaction, because at that time, like it is following that that triad, that is the basic principle of the cryptography. That is the availability, encryption, and confidentiality, and the authentication. So those things are there, but during the transaction, there is a vulnerability inside the blockchain. So still a lot of effort is going on to remove those vulnerabilities also. And if ideally we are going to implement it, then the system can be more efficient, as the role of third party will be removed from these systems, from the blockchains. All right, so little bit about the cryptocurrencies. Everybody knows that cryptocurrencies are nowadays very popular. People are investing in crypto, and they are like earning huge money also in terms of crypto. So if we can compare with the existing systems, we can say that earlier our money was sent to the bank, and they are being with the help of some of the third parties or intermediaries. They are charging fees like Visa, MasterCard, or PayPal. So, and then finally it is reaching to the beneficiary. But now after the Bitcoin, nobody is there in between the two peers. All right. So basically, the cryptocurrency is an internet-based medium of exchanges which uses the cryptographical functions to conduct the financial transaction. So the all operations are digital. They are decentralized. They are working. They are being operated on a peer-to-peer system. Nobody is having their identity open. Like who is transferring the crypto to whom, nobody can know this. So that is, the transactions are pseudo anonymous. You have only a public address that is given to you, and that public address is of your MetaMask or any wallet's address, and that address is only the identity in your blockchain. Then we have it is trustless, it is encrypted, and you can do the transactions globally. Like somebody sitting here in India can send the Bitcoin to any part of the world. So there is no need of any of the third party for doing that. But there are some of the challenges like related to regulations also. So still there are, these things are being taken care of, and they are in the process. Some of the other cryptocurrencies apart from Bitcoin are like Ethers, Ripple, Litecoin, Libra, Bitcoin Cash, Matic, DAO, MakerDAO. So these are all kind of some of the more cryptocurrencies that are existing nowadays. Now, let us briefly discuss about some of the blockchain use cases. Like we can develop the blockchain for maintaining the digital rights, like digital identities. Like we are having Aadhaar system, so all Aadhaar can be implemented onto the blockchain. We can have the salary transfer systems onto the blockchain. We can have the property record of properties or land records onto the blockchain. We can have the equities over the blockchain. We can have some of the crowdfunding for any of the project through the blockchain. Maybe the person sitting in US, he is interested on a particular project, irrespective that who is doing that project. So you can do the crowdfunding with the help of the blockchain. We can have some of the e-commerce applications for global payment applications, healthcare applications, agriculture applications, intellectual property rights applications, elections over the blockchains like voting systems. We can also maintain the microfinances over the blockchain. So these are some of the blockchain potential applications and disruptions that we can have over the blockchain. Now, if somebody is more interested in creating their distributed or decentralized applications, which is known as DApp, so these are typical abstract steps that are needed. All right. So we have to define in the beginning that which kind of blockchain we are going to use, whether we are going to use a permissioned blockchain or a public blockchain. So accordingly, we'll choose the kind of blockchain, whether we are going to choose it for Hyperledger or we are going to choose for Ethereum. Then we are going to build the prototype for it. That is through the rapid prototype. So proof of concept that we are going to build it. So that proof of concept will have a web application or a mobile application with the help of some of the web development tools. Then we will develop some of the front end with the help of like React, Express.js, Node.js, MongoDB, some of the databases. And then we will build the backbone, that is the smart contract. Role of smart contract will come as we are going to build the backbone of our decentralized application DApp. Then we will use some of the tools to find like how we can select those tools for the deployment of our DApp. Then we are going to test that DApp and then we can launch or deploy that DApp. All right. So these are some of the suitable tools that we can use as a student. You can use these tools for the development of your decentralized application. So if somebody is interested in blockchain development, you have to learn JavaScript. You have to, for the purpose of front-end development and for the testing of the smart contract, because the Web3 is completely written into the JavaScript. All right. So because your smart contract is basically communicating with the blockchain, with the front end. So that is done with the help of the JavaScript. Then we will write the smart contract. It is in Python, Golang, or Rust, or C++. And then the smart contract development can also be done with the Solidity and Node.js. So there is a framework that we use for the blockchain, that is Truffle, so that we develop smart contracts with Solidity. We test this blockchain code over the Truffle. We use the MetaMask for the purpose of maintaining the cryptocurrencies or any of the assets that we are going to transact over the blockchain. All right, we will have some of the tools like Ganache. That Ganache is basically kind of a tool that is used for the local hosting onto your machine. So, for example, if you don't want to use some of the blockchains or some of the like Truffle kind of a thing, you can use the local host for using Ganache. So Web3.js, Ether.js, Express.js, Remix is kind of an online IDE that can be used for writing the blockchain code. And this Remix is supporting all the languages like Solidity, or you can write it JavaScript also, Golang also. So Remix is kind of a very popular IDE that we can use. All right, so these are some of the suitable tools that are being used for the purpose of decentralized application development. Now, so in the present, if we talk about the present perspective of the blockchain, so basically now, till now, our focus has been on the cryptocurrencies only. So whenever we are talking about the blockchain, so everybody is understanding blockchain means cryptocurrency, but it is not true. Now the momentum is shifting gradually away from the cryptocurrencies, and it is moving towards the decentralized ledger technology enterprise applications, like all the use cases which we just discussed. Like you can have a supply chain kind of a thing. You can manage the salary of the employees. You can do like so we have to decide that whether the blockchain is suitable for our business logic or not. But now the momentum is shifting towards the enterprise applications from the cryptocurrencies. So presently we are in the transitioning phase from cryptocurrencies towards the enterprise applications, and this will be done. Presently we are doing it for seeking and tracing the provenance of the origin of the assets from where a particular transaction has originated. So that can be done with the help of blockchain. Like for example, we can have like Nestle is basically has given or is basically developing a prototype for milk supply chain blockchain to trace the milk source. So in that case, whosoever is purchasing the Nestle's milk will have a higher confidence, because he is knowing that from where this milk is coming, at what time, at what place that milk was stored, and what was the like place. So there is a complete tracking and tracing of the milk. Also, we talked about the car mileage case. So Bosch has already developed that prototype, and that prototype is being under development. So we can have these kind of things, and presently we are doing it. So what is the future? The future is really wonderful, and a lot of investment is going to be infused inside the blockchain. And you can see here, like by the year 2025, blockchain would add a business value that will grow to over $176 billion. And this would further increase by 3.1 trillion US dollars by 2030. So by 2030, it could be used as a foundational technology for 30% of the global customer base. So you can understand that down the line, 7-8 years, many of the businesses will be shifting over the blockchain. So you can understand that if you are really passionate about the blockchain, you are going to have a great future ahead. So, but still we are having challenges. The challenges are like performance and scalability, because the transaction rate over different blockchain is variable. That is not uniform. Performance is a kind of problem, like a lot of energy is required, a lot of computing resources are required, a lot of storage is required, because we are storing the copy of the transaction on every peer. So there is a lot of duplication, replication of the records. So how we will handle that from security perspective also. So this is a challenge. Again, like if we are having the records that are stored onto Ethereum, then how those records will be accessed from the hyperledger. So there is an interoperability issues also that are part of the blockchain. And data localization policies for the data protection is also one of the challenge. So data regulation bill or some of the regulations has been developed, like UK has developed their regulation bill for the data protection, and they have already in place that policy. So still a lot of things, a lot of challenges are there we have to face for getting into the position to deploy our business logic onto the blockchain. All right, so let us come to the summary of this talk. So definitely blockchain is an emerging technology that is going to drive the business logic in the future, and it is going to work as a trusted exchange for all the digital operation in the digital world. All right, so blockchain will have different technologies like DLT. It has peer-to-peer network. It has immutable records. It has smart contracts. It has the consensus algorithm, and it will be using some of the data models, language transactions in terms of for the development of the smart contracts, consensus algorithms. and we can have either permissioned or non-permissioned platforms, that is private or public blockchains. All right, so that's all from my side. I hope I have finished on time. So, Dr. Tribhuvan,
Yes, sir. Thank you so much, sir,
yeah,
for such nice.
any questions? I am open for the questions now.
Okay, so is there anyone who is having some queries? Yes, any query?
Okay, I think there is no question. Initially, I had few questions in mind, but sir, during your presentation, I got some of answer, so I'll skip to that. So,
Sure, sure. Thank you,
okay.
sir.
So, this was a very nice presentation from the past, present, and future, and also it was very simple and it was very interesting. The way you have presented the infographic manner were really interesting. So, on the behalf of this Computer Science and Engineering Department of Shiksha Anusandhan University, I would like to express our deepest gratitude to Dr. Vimal Kumar. And with this also, I would like to thank our faculty coordinator, Dr. Tribhuvan Singh, and our convener, Professor Devoti Misa. Also, I would like to express my thanks to the organizers, Dr. Sadhakrishnapathi, Dr. Vishnu Das, and Dr. Mahadev. Also, I thanks all the audience for their patience and time. And thank you once again, sir, for presenting this. Also, this was very interesting to me. I look forward to catching you again.
Sure, sure, sir. I am also thankful to you all, sir, to all the organizations for giving me this opportunity to interact with your students. And I am having my email address written over here. I am having my number also with Dr. Tribhuvan. If anybody is interested in further collaborating with me on blockchain technologies, I am really interested and passionate about some of the use cases. So if somebody is interested more, we can collaborate also together.
Yes, that will be great, sir.
Yeah.
Thank you.